afternoon, ladies and gentlemen. My name is Dr. John Belkwitz. I'm the Director of R&D here at Intelligent Concrete, and we're here to talk to you today about resilient floors with colloidal silica and how to cheat the system. If you've never put on a resilient flooring system, or you don't even know what a resilient flooring system is, let's show you what it is. Ding! So that means Haley just showed a picture of a resilient floor. So a resilient floor, my favorite, I wouldn't say it's my favorite, but it's definitely the most popular, is these vinyl floors that you'll see in Walmarts, you'll see them in food stores. It's that vinyl tile that has an adhesive under it, and then of course under the adhesive is normally a concrete floor. So when I say how to cheat the system, I guess we kind of have to explain the system. So years ago, somebody convinced the world, sorry, I was playing with too many markers. Somebody convinced the world that it was a good idea to put a glue on top of concrete and then put some type of tile or carpet or laminate flooring on top of that glue. Now everything was working great when we were still making those glues out of solvent-based materials and we had breathable asbestos tiles. But years ago, laws changed, so now we have water-based glues that are sensitive to moisture and alkalis, and we also have tiles that are no longer breathable, these vinyl tiles. So we've got an environment that we're creating that is just really not conducive for these resilient floors. And whoever convinced the industry that concrete was a great medium for a moisture and alkali sensitive glue with a sealing membrane over it, I gotta meet that person. Definitely gotta meet that person. It's a horrible idea, but we still do it, and we do it every day. And one of the things that we learned is a great book. Where's that book? I think I put it back. Hold on a second. There's a great book by Howard Knar called Concrete Floors and Moisture. And it really goes into just everything that we have to worry about when it comes to the history of it, when it comes to resilient flooring systems, concrete floors, the moisture-related things that deal with it. And there's I think it's page 41, he goes into this cheat sheet on, how to decide or how to identify when our floor is going to be ready for, the resilient flooring system. And, I believe within the standards, F3 or ASTM F3010, and back of the soup can, you have an 85% relative humidity, and somewhere below 5 pounds per 1,000 square feet over 24 hours for a moisture vapor emission rate is what we need. And with Howard's tables, you'll find that somewhere around 30 days for every 1 inch of concrete thickness. So if you have a 4-inch thick slab, it's going to take you about 120 days to get down to an 85% relative humidity, blah, 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 blah. Now, the harsh reality is in our industry, folks don't normally do that. They might wait 3 days, they might wait 7 days, they might wait a really long time, but the slab will be open and be used for construction. But more often than not, folks are trying to get the flooring on as soon as possible. So that means much less than the 30 days for every 1 inch of concrete, or for a 4-inch thick slab, 120 days. Now, how does concrete help you get past that? Well, there are some folks who believe that it's not the relative humidity that matters. It's the relative humidity in combination with the moisture vapor emission rate. So relative humidity is the amount of moisture that's within the slab, that's contained, and if you can compare it to energy, it's like potential energy, while moisture vapor emission rate, the actual moisture emitting out of the slab, is your kinetic energy. So we have a lot of potential with our RH, but if you have a concrete, a good foundation that's designed to hold in that moisture, you're not going to have that vapor emission rate or the alkalis that go with it that'll cause the hydrolysis of the glues and the delamination of the tiles. And basically that's what we get out of colloidal silica. It allows us to cheat the system, and inevitably we're going to cheat the system. That's what our industry is currently doing. But inevitably it allows us, or it gives us the umbrella of insurance to cheat the system if we're already going to do that by locking that moisture in, as well as locking those alkalis that would contribute to that breakdown of the glue and the delamination of the tile, and ultimately a failure of our resilient flooring system. So hopefully you learned something today. Let us know if you got any concrete questions or concrete concerns. Don't forget to like and subscribe. Ding that bell for notifications. Go concrete!
Beat asphalt!